welcome to another brand new edition of Chemistry Neco Practical 2025. How to determine endpoint without doing the practical. How to determine endpoint using calculation method. Now, this method is the best approach so that when you get to the lab, when you'll be doing your practical, you should know exact thing that you will be doing. Okay, so we have done this in during WAEC. So WAEC, exactly what Mr. Mike YouTube channel predicted, that is the exact thing WAEC gave. Okay, ranging from SWOT analysis, we did on SWOT analysis exact the same thing, and also we did on how to determine endpoint. The same thing came out, and the question that you are expected in this in WAEC exact thing came out. So we are into another edition of what? Neco, how to determine endpoint, how to determine Neco endpoint in chemistry. Or is that okay? So we are going to go direct. If you are joining us for the first time, this is Mike YouTube channel. Just click on the subscription button to get the latest update. Subscribe so that you can be getting the latest update on the happening of what? Chemistry. Remember, this is what quantitative analysis, that is titration. We are going to do SWOT analysis, so don't forget to subscribe. Okay, now are you a chemistry teacher and you want to know how to be determining endpoint without doing practical? Then Ojema YouTube channel is the best for you. Now let's go. What Neco gave what they gave for the practical things is what? One, they gave acid. You say HNO3. They gave 6.30 cm cubed. This is what they gave. Your salt, they gave you two salt. Is that you should mix two salt. One of the salt is Na2CO3 and another one is NaNO3. This one is 5.5 grams and this one is 2.5 grams. Now, this is what Neco have given you, that you should dissolve this one into what? 1000 D. Of course, before you prepare it, this is a concentrated one. 6.3 is a concentrated triazonitrate acid, and this one you have to mix this one. Then you now use, after you dissolve this one, then you now use it and titrate. Then you now get your volume of what? Acid. You get that? Now you have to mix these two things together. Let me tell you what they want to confuse you. How they want to confuse you is that you have to mix this salt and use it and titrate this one. You will be wondering, if I mix this one, how will the equation react? Let me tell you, this one now is a neutral salt. Acid-base titration is you are titrating acid against base, not acid against neutral something. Is that understood? So this one is a neutral salt. There is no way in chemistry, there is no way this acid can react with this one. There is no way. You get that? So this one is just there to confuse you. Is that understood? It's just there to confuse you. Now, what you should be thinking of is the percentage of impurity which they are going to ask. What is the percentage of what? Pure acid, sorry, pure base. What is the percentage of pure base? That's what they are going to ask. So this one does not have, because if you mix this thing together, this triazonitrate will rather react with this one, and this one will just be left alone. So the equation for the reaction will be what? Will be HNO3 plus what? Na2CO3 will give you what? You sodium nitrate plus what? CO plus water, H2O plus what? CO2. So to balance the equation, you have 2 here, I have what? 2 here. So this is the equation of the reaction. This one, I told you that is a neutral salt. It's a neutral salt. If this one cannot react with this one, it's just like HCl plus sodium chloride. It cannot work. You get that? Now, since we have known our equation, let us go. We want to determine the endpoint. Let us go and determine the endpoint. We go to this one first. We have to calculate the. We want to learn. You are going to know the most of this one. Know the most of this one, so that we can put it in our formula. This one, remember, the molarity of HNO3, the molarity is equals to what? 16 moles. All right, the molarity, I mean the percentage, this 16 mole is derived from the percentage purity and the density of the acid. The percentage purity of this HNO3 is what? For you to determine this 16, how we got this 16 is what? Is molarity molarity is equals to purity times density all over molar mass. How to get this 16 is this one. Percentage purity is what? Is of triazonitrate acid is what? Is 68%. The density is what? The density is 1.4642. This is the density of this. That is gram per milliliter. Do you get that? And the molar mass of triazonitrate is what? Is 63. H here is 1, nitrogen here is 14, oxygen here is 16 times 3. You add this together, give you what? This. But then this one is in percentage. You need to convert it into what? Convert the percentage. So you see 68 divided by what? By 100 times this one. You need to convert it into liter. All right, so it will be what? 1.42 times 1000. After you have done everything, divided by what? 63. You have 15 point something. But in the laboratory, what we normally use is what? The molarity of this one is what? 16. All right, now having gotten this thing, now you are asked to dissolve this one in what? 1 DNK. So what you are going to do is that we are looking for our what? Our Ca. Now Ca, now we say Ca is equals to 6.30 divided by what? By 1000. You multiply by what? By this molarity. Do you get that? So when our Ca now will be equals to what? Use our calculator, don't forget. 6.30 divided by 1000 times 16. We have what? We have 0.1008. Going further, we want to look for our Cb. All right, Cb, we are given. Remember, we say we are not going to use this one because this one react with this one. So to get your Cb, you use the formula mass over what? Molar mass. Mass over molar mass. Now, what is your mass? Mass is 5.5. Divided by what is the molar mass of this one? So we are going to calculate the molar mass of this. The molar mass is what? Sodium here is what? Sodium is 23. Sodium is 23 times has two atom, so times 2, plus carbon is what? 12, plus oxygen is what? 16. 16 times this 3. 16 times 3. So at the end we have if you calculate this one, you have this one times this will go 46 plus 12 plus what? 48. At the end we have 106. So we are going to divide it by what? 106. So 5.5 divided by 106 equals to what? What we have is 0.052. We approximate it to 2 moles. So this one is mole, this one is what? Moles. Now our Cb now, Cb is equals to what? 0.052. Do you get that? So now we are now going to use a formula. All right, let me wipe this off. We are now going to use a formula, and this formula is CaVa all over CbVb times Na all over. Is that understood? So now we want to make our VA because we are looking for volume of acid. VA now will be equals to what? You are going to look at this one will go here and this one will go here. So this one that is 3 now will be on top. Is that okay? So we have CB, VB, NA all over what? All over CANB. Don't forget that your CB, you have already gotten your CB, you have already gotten your CA. What is your VB? The volume of prepared is given as what? VB is equals to what? 25. You are going to use that one that used in pipetting is what? 25. Now, what is your mole ratio? Na and Nb. Na is what? What is the mole ratio of acid here? What is in front of this acid is what? 2. That is what we call mole ratio. What is in front of this base here? Nothing is here. So is what? So acid is what? 2 and base is what equals to what? 1. Nothing is here and 2 is in front of this one. So we therefore say VA now is equals to, what is your CB? CB is 0.052 multiplied by, what is your VB? Look at your VB here. VB is what? VB is 25 multiplied by, what is your NA? Look at your NA. It equals to what? 2 divided by, what is your CA? CA is what? CA is look at CA here, 0.100. Or you can leave it to 1 decimal, 2 decimal place, anyhow you feel like, times what? Times 1. So VA now will be equals to, if you multiply this one, will give what? 2.6. Let's say 0.052 times 25 times 2 equals to 2.6. You divide by what? 0.1008. So divide by 0.1008 is equals to what? Equals to what? We have 26. Or you can approximate this one. 2.6. You have 2.6 divided by 0.101. So we have 25.7, but you approximate it to what? 26. So your volume 2 cm cubed. So your volume of, you have 25. If you can divide this one, we give you what? 25.74. So you just approximate to what? 26. Your endpoint should be what? 26. So the endpoint of 2025 Neco chemistry practical is what? 26. You can use 25 theoretically. Let me just put it like this so that you will not be confused. You have 25.774, but this value is not obtainable. You cannot have okay, let me just put it like this. Theoretically we have 25.74. that is theoretically. Do you get that? So you can approximate it to what? To 26. Okay, so 26, let's say you approximate to what? 26. So our endpoint for 2025 Neco practical is what? 26 cm cubed. Is that understood? So this is the legit update. So if you are watching for the first time, are you a chemistry teacher? Just hit that subscription button. I'm going to wipe the board. Look at the approach. I'm going to wipe the board and set this one is 11 mark. So what you are going to do is, on top of the table, first thing you are going to write is volume of prepared. Volume of prepared, write what? 25 what? cm cube. That is what you use in pipetting. 25 what? cm cube. Indicator. So you must write the indicator. Now you now go back and draw your table. The table is you have burette reading, you have first title, you have second title, and you have what? Third title. This is how your table should look like. Under burette reading, you have final reading, all must be in what? In cm cubes. Is that understood? You have initial reading, all in cm cube, and the last one is volume of acid. Volume of acid used, all in what? cm cubes. So now in your initial reading, because you are just filling the acid in the burette for the first time, your initial will be what? 0.00. Remember, this decimal place must always be in 2 decimal place. Do you get that? Your final reading is what? We say we have 20, let's say 26.70. That is what probably you have, and at the end you have what? 26.70. Now as you proceed, there is no way you can use this acid, because it has the that burette is calibrated from 0 to 50. So this one has passed the half mark of that of 50. So you need to refill that little. So you put it on 0.00, and at the end you have 26.00. Minus this one from this one, you have what? 26.00. And at the end you refill it again, and you have what? 26.0. You have what? 0.00. You have 26.100. So I have 26.100 as your volume of acid. Now there is what Waye will always want you to do. You are expected to get the average volume of acid. To calculate the average volume of acid, average volume of acid, the mistake people used to do is that they will take the whole this thing, or sometimes if here is 26.7, here is 27.7, here is 20, they will take the 3. No, in the instruction or Neco will give you what? Repeat the titration to get your concordant value. Concordant value means the number that are the same. That is the one you are going to use for your average volume of acid. Do you get that? So now you have what? First title. Yeah, we have first title, but if you look at the concordant value here, you have 26.00, 26.00 is the one that is almost the same. In fact, it's the one that is the same. So this one is, there is 26.7 here. So we are not going to take that one. So we are going to say second title plus what? Third title divided by, because we are using only 2, 1 and 2, so divide by what? 2. Do you get that? So at the end we have 26.00 plus 26.00 divided by what? Divided by 2. So we now have our volume of acid as what? Average volume of acid is equal to what? 26.00 cm cubed. Always put your this thing in 2 decimal place. So now this is the table on how you should be able to get, so that you get your complete 11 marks. Complete 11 marks is, this is the table. Do you get that? Your decimal point must always be in 2 decimal place. On no account should you go and use like now 27.5 or 27.1. No, because burette reading is only calibrated from like now 0. You have 1.1, 1.2, 1.3, 1.4. There's no 1.51, 1.52. No. So if you put that number there, for instance, I say 45